All right, this is Unit 3, Lesson 4 of our calculus class. Unit 3 is called Implicit Differentiation, as well as inverse functions and just a few other hodgepodge things we need to clean up. Lesson 4 is on derivative of inverse trig functions. So what we're going to learn in this lesson is how to differentiate sine inverse, cosine inverse, and tangent inverse using implicit differentiation. And so if you remember, we learned to derive all 6 trig functions, sine, cosine, tangent, secant, cosecant, and cotangent, before by using the quotient rule. So low d high minus high d low over low squared. So to find the derivative of the inverse functions, we first need to know how to do implicit differentiation. Now we've done that, so here we are. Okay, so if I want to take, well, first of all, I'm just going to tell you that the derivative of sine inverse is 1 over the square root of 1 minus x squared. And if you're going, huh? What? Just remember that we're working with sine, cosine, tangent. We're working with the sides of a right triangle you could think of. And so if we think of Pythagorean theorem, this this answer might make a little more sense because this kind of looks like c squared minus a squared, you could say. So anyways, let's try this out. So if we want to derive sine inverse of x, first we will say let x equal, or let sine of inverse of x equal some value y. Well, by definition of inverse, we could say, okay, well, if sine inverse of x equals y, then x would be equal to sine of y. Okay, and so sine of y is a function that we already know how to derive. So if I take if I use implicit differentiation, I can take the derivative with respect to x of x, and it's going to be equal to the derivative with respect to x of sine of y. And so implicit differentiation, we are treating every variable like its chain rule. So the derivative with respect to x of x would be dx over dx, which is just 1. And the derivative of sine of y would be a chain rule. We have cosine of y times the derivative of y with respect to x. And so if we solve for dy dx, we just divide each side by cosine of y. We get 1 over cosine of y equals dy dx. And so now what I want to do is take this a step further, because I don't want to leave my derivative of y in terms of y. I want it to be in terms of x. So I need to take cosine of y and convert this into x. Okay, and so how I'm going to do that is I'm going to consider the Pythagorean identity. Sine squared of y plus cosine squared of y equals 1. And we just kind of pulled this out of our pocket. It's a trig function we know. If there's any single trig function you remember from this class, please let it be this one. So if we take this thing and we solve it for cosine of y, we would end up with cosine of y would be equal to the square root of 1 minus sine squared y. And so now, because sine of y is x, well, if sine of y is x, sine squared of y would be x squared. So this is where we take sine of y and we replace it with x. And so sine squared y would be turned into x squared y. And then now we have a equality here for how to turn cosine of y in terms of an x value. Cosine of y is equal to the square root of 1 minus x squared. And so because of this, I'm going to take this and replace our cosine of y in our derivative equation. And we're going to end up with dy dx equals 1 over the square root of 1 minus x squared. Okay, so now if that makes sense, then we can kind of look at the derivative of cosine inverse, and it's an analogous procedure. Just some of the parts, some of the like cosine and sine are reversed. If you recall, so the derivative of cosine inverse is negative 1 over the square root of 1 minus x squared, which is very similar to the derivative of sine inverse. And so the fact that the derivative of cosine inverse is negative should make sense, because the derivative of cosine is negative sine. So the derivative of cosine inverse, it should be no surprise that this is also negative. Otherwise, it's the same as derivative as sine. And again, it's kind of an analogous procedure for solving. Okay, now tangent is a little different. It is a similar procedure, except we're going to derive tangent is going to be secant squared, and we're going to use a different trig identity here. And so we could start with sine squared plus cosine squared equals 1 and turn it into tangent, or turn it into terms of tangent. Or we're just going to say, okay, we've got a second trig identity that we can pull out of our pocket from pre-calc. So tangent squared plus 1 equals secant squared. That's just one of our trig identities. It's categorically, it's one of the Pythagorean trig identities, but we're going to go with it. So we're trying to replace secant squared of y. So if we know tangent squared plus 1 equals secant squared, and we know that x equals tangent of y, I'm going to replace tangent squared of y with x squared. So we get x squared plus 1 is equal to secant squared of y. So I could take my x plus 1 and replace it with secant squared of y in our derivative. So we get 1 over x squared plus 1. All right, so some examples here. A quick reminder, there's two ways to write inverse trig functions. So we could say our exponent of -1, sort of. So sine inverse, cosine inverse, tangent inverse could be written like that. We also use the term arcsine, arc cosine, and arctan. Those mean the same thing. It's just two ways of writing it. Yeah, I think someone just had to feel special and make it their own way, I guess. I don't know. But just know those mean the same thing. Again, we have our derivatives for sine inverse, cosine inverse, tangent inverse, all on one slide. If you're taking notes, hopefully this makes it a little easier to summarize. Here's some examples for uh, finding f prime at a given point. So the derivative of cosine inverse is -1 over the square root of 1 minus x squared. If we're going at a point square root of 5 over 3, we're going to plug in the square root of 5 over 3 into our x value in our derivative equation and just solve this thing out algebraically. Okay, so we have if f of x equals arctan. Remember, arctan is equal to tangent inverse, same thing. So the derivative of tangent inverse is 1 over x squared plus 1. So we'll plug in the 4/5 in for x. So it'll be 1 over 4/5 squared plus 1, and then we'll do the calculations there. Okay, so just finding f prime, tangent inverse of x to the power of 3 will be a chain rule. So we'll do tangent inverse and leave the x3 in for x. So it'll be 1 over x squared plus 1 will be 1 over x to the power of 3 squared plus 1. And then we'll multiply that by the derivative of x to the power of 3, be 3x squared. So we got 3x squared over x to the power of 6, multiply powers, plus 1. All right, and then again, arcsine means the same thing as sine inverse of 4x. Because we have 4x inside of a sine function, that's going to be chain rule again, so multiply by the derivative of 4x. We'll get this answer right here. All right, so we can use implicit differentiation to derive our inverse trig functions. That's good stuff.